Hey, gang, Mr. Cruze here with a finite video lesson for you. I'll try to make this short and sweet for you. This is actually the last section of chapter 1. We're going to take a couple days on it, but we're going to talk about sets of outcomes and trees, all right? And this is going to lead us into a unit on probability. So, a couple vocabulary terms for you to start off with. We're going to talk about experiments a lot, okay? You're going to hear, things like trials and experiments and all sorts of things, and all sounds very, sciencey, and we're going to do physics, we're going to need goggles, and we're going to be blowing up labs and things like that. That's not the case at all. Mathematical experiments are a little bit different. We do fun stuff like roll dice and flip coins and draw cards and talk to people and document the results of phone calls and things like that. Those are all examples of mathematical experiments, okay? Anything with a sort of outcome that we can document, that is going to be our experiment. It's not necessarily that we're growing plants with different types of water and things like that. You could do that, but we're more interested in eventually random phenomena. But that's what an experiment means. Okay, so please don't feel like we're going to do physics or anything. I promise. Each of our experiments has possible outcomes, obviously. So like flipping coins, you could get heads or tails. Rolling a standard die, you could get 1 through 6, right? Those are just we sometimes call them consequences, which sounds like it's a bad thing, but it's not. Or results of the experiment is another way you could say that, okay? And it's those sets of outcomes. It's the set of those outcomes that we are interested in. Not only what are the possible outcomes, listing out all the possible outcomes, but also the number of them. We're interested in figuring out the size of those sets, which is, again, why we've been spending time talking about the size of sets, all right? So a sample space. A sample space it's just a set, okay, consisting of all possible outcomes of an experiment. So, for example, easy experiment here. If I just flip a coin, my sample space consists of heads or tails. That's the set. That's the sample space. It would be H, comma, T. That would be your set. Okay? It's a set consisting of all possible outcomes of an experiment. Basically, think about it as the universal set for an experiment. It's literally every possible outcome that could happen. It's essentially a universal set. That's it. As it is still a set, be sure to use brackets as it is actually a set, and you need to denote it as such. Usually sample space you'll see written as S. That's usually the name we give it. You don't have to do that, but it's common mathematical practice. So let's try a couple of examples here. So an experiment consists of making 3 phone calls. We're going to call 3 people, one after the other, and noting in order whether each call is answered. So we are going to describe the set of outcomes of this experiment, and we are going to form a sample space. Describing the set of outcomes, we don't need to get too terribly crazy. Just kind of talk it out with yourself. Obviously, each phone call, a couple different things could happen. You could, for example, the phone call could be answered, or it might be unanswered. All right, and again, we're not going to differentiate between what happens if it goes to voicemail or anything like that. Just whether the call is actually answered by a person. All right. So form the sample space. So we're going to call the sample space S. Obviously, it is a set. So what could happen here? Well, your first phone call could be answered. So we'll go with answered as A, and we will say unanswered is just U. We'll use that. So we could have answered, answered, answered. All 3 phone calls could be answered right in a row. Boom, boom, boom. It could so happen that we could get answer, unanswered. We could so happen to get answered, unanswered, answered. We could so happen to get answered, unanswered, unanswered, right? And then we could also get very similar outcomes, except what if the first phone call is an unanswered, right? So we could get unanswered, answered, answered. We could get unanswered, answered, unanswered. We could get unanswered, unanswered, answered. Or we could get unanswered, unanswered, unanswered. Those are all the possible outcomes, and you could always count those and obviously see that we have 8 outcomes. All right? What about rolling a 4-sided die? So literally a die that just has numbers 1, 2, 3, and 4 on it, and recording the result of each roll as even or odd. Okay, so we're going to roll it twice and record the result of each roll as even or odd. So the sample space here, well, what could happen? Well, the first roll, obviously, is either going to be even or odd, right? It'd be even if I got 2 or 4. It'd be odd if I got 1 or 3. So my first roll could be even. My second roll could be even as well. The same thing could happen. I could get even and odd. I could get odd and even. Or I could get 2 odds in a row. Okay? Again, E representing even, O representing odd. That's all the possible outcomes that could happen. It's not possible to get even 5 or something like that. Like you can't possibly get anything outside of this sample space. Here's another example. How about we consider an experiment where we are making 3 phone calls, so like before, one after the other, but this time we want to note the number of answered phone calls. Just the number. I'm not interested in the order of answering or unanswering, whether or not they did. I'm just interested in the number of answered phone calls. Well, what could happen? And you can actually go back and look at the first one that we did and actually count, right? Like if I make 3 phone calls, obviously, I might get 0 answered. All 3 people might just totally ignore me. I could get 1 answer, right? Could be the first person, could be the second person, could be the third person. Doesn't matter. That would all fit as 1 answering the phone call. 2 could answer, right? The first 2 could answer, the second 2 could answer, or the first and the last could answer. Or I might get lucky and all 3 people will answer. So that is my sample space. So notice, sometimes depending on what the experiment is, like what you're recording, can actually change the sample space of your outcomes. All right, so you do kind of have to pay attention a little bit to what exactly are they recording. All right. Now, obviously, examples are going to get a little bit more complicated than this. But for now, we're keeping it pretty basic, okay? Just trying to list out all the possible outcomes. And sometimes you do have to think about it a little bit outside of the box. Eventually, we'll have pictures to kind of help us figure that out as well, because as I've said before, we're very visual people. All right, your homework, the ones I want you to try. I want you to try 1, 3, 5, 7, 9, 11, and 13. My sub should pass out the 1.4 homework for you. This is 1.4 homework, obviously. The 1.3 homework that you still have, I want you to finish that up today. It is due tomorrow when I get back, so I want to make sure that you have that done. Obviously, I'll take questions if you have any. You can always email me. But I do want you to kind of start on these 1.4 questions as well. You should be able to do them at this point. All right? That's it for you. Have a wonderful day, guys.